morning friends, and in this video again we are continuing our journey of solving the different type of differential equations. Now last time, in the last video actually, you learned how to form a differential equations from the given equations by eliminating the parameters, and these parameters were just the constants. Since we know that the order of the differential equation is same as the number of parameters involved that particular equations. Now in this video we will convert a given family of curves to a differential equations. How? So the equation goes like that: if a family of curve f1 has one parameter, then the equation of the family of the curve goes like x, y, a is 0. This is the family of the equation and this a is the parameter. But if it has more than one parameter, like it has two parameters, and if the family f2, so same thing, if the of curve f2 has two parameters a and b, then the equation goes in the form of f2 x, y, a, b. Now here you see that when it has only one parameter, then we get this parameter eliminated by differentiating once. So the shortcut is differentiating once, and here you have to differentiate it twice because it has two independent variables. Now these are the just general format. Now when you are given an equation, then only you determine that how many parameters it has and how many times I need to differentiate to get rid of that parameter. But the general logic says that if it has one parameter, then the order should be dy by dx to 1. The one parameter, then order is 1, two parameter, then order is 2. It means if there is one parameter involved, we have to differentiate only once, and if it has two parameters, then we have to differentiate twice. So now let's get back to the questions, because solving the questions only will tell you that how we should frame the equation, how should we find the equations of the differential equations. Now we'll take some family of equations. So exercise 9.3, question number 6. The first questions, I have taken the photograph of these questions, you see. So the first question is that form a differential equation of the family of circles touching y-axis at the origin. So we have to find the differential equation of the family of circle. So this is my x-axis, y-axis. Family of circle touching y-axis at origin. So touching y-axis at origin means your circle will be like this. Like this, and this will get the family of circles. Now why they are calling family of circles? Because you always get family of circles by differential equation. Now you may ask how. So I take one simple example before solving this. Suppose if I want to find out the equation of a circle with the center 0, 0 and the radius a. So this radius is a. So a 0. So now if you find the equation of the circle, you get x square plus y square is a square. Now just consider a as your arbitrary constant, and you assume that, so this is when you assume that a is arbitrary constant but parameter, okay, so if instead of calling arbitrary constant, if I call it as a parameter, like a is going to determine the value of x square plus a square. So if I say that if a square is 4, so this becomes x square plus y square. Like if I say a, this is called the general equation, and if a becomes 2, then you get a particular circle, x square plus y square is 2 square. So this is the equation of the circle with the center 0, 0 and the radius 2. If you take a as 3, this is equation of circle with the center 3, like that. So you always get a family of circles if you keep on changing the values of a. That's why here also the same idea is applied. Now let me remove this part and get me back to we are trying to convert a given family of curves into differential equation, and here we were asked to find the differential equation of a family of circles which touches the y-axis at the origin. So this is one possible case. For case of simplicity, I will only draw one circle, not to confuse you. So remove all these, and later you will automatically get your family of circles depending on the parameter. So now this is, suppose I say that this circle has center A at a comma 0. So we know that the equation of this kind of circle is x minus a whole square plus y square is a square. Now I expand this, so I get x square minus 2ax plus a square plus y square is a square. So a square cancel, then you get x square minus 2ax plus y square is 0. Now this equation has only one parameter, that is a. It means we have to differentiate it only one time. So what to do? Now differentiate this implicit relations once, differentiate both sides with respect to x. So I expand this equation, I get x square minus 2ax plus a square plus y square is a square. Now this a square cancel each other. We have x square minus 2ax plus y square equal to 0. Now I differentiate this equation to eliminate this a, then what do I get? 2x, here I am not writing, so let me write this, differentiating both sides with respect to x. So 2x minus 2a plus 2y dy by dx equal to 0. Then I take this 2 common, and so this becomes x plus y dy by dx equal to a. So I have taken 2 common, at the same time I took this term on this side, so I get x plus y dy by dx is a. So I am going to put this value into this equation, because this equation is the same as this, only it has been simplified. So we get x square minus 2a. What is a? That is x plus y dy by dx plus y square equal to 0. This is your differential equation. One problem. So 2ax, we have to write this x also here. So now if I simplify this, I'll get x square minus 2x square minus 2xy dy by dx plus y square equal to 0. Now it becomes minus x square minus 2xy dy by dx plus y square equal to 0. If I take this minus x square common, and then I write this dy by dx first, then I'll get 2xy dy by dx plus x square minus y square is 0. And this is your final answer. Question number 7. Form the differential equation of the family of parabolas having the vertex at origin and the axis along positive direction of y-axis. So the family of parabolas with the vertex at origin and the axis is along the positive direction of x-axis, means this parabola will be like this. So this is my parabola. If you take its focus at a comma 0, then its standard form will be y square is 4ax. So equation of parabola is y square equal to 4ax. Now differentiate it. So differentiating both sides with respect to x, we get 2y dy over dx as 4a. It means y dy by dx is 2a. Now at the place of, here also at the place of 4a, I can directly write this much. The equation will be eliminated. Since we already have y square is 4ax, at the place of 4a you write 2y dy by dx. So this becomes y square 2y dy by dx, and this is x. 1 y gets cancelled, then you are left with y is 2x dy by dx, or you can write 2x dy by dx minus y is 0. This is your answer. So this is question number 8. So I want to make it clear that the question number 7, my answer did not match with the textbook's answers, but I checked it twice and then I found that my answer was correct. I believe that I may be wrong, but if you find this is wrong, you can make the corrections and make it ready, because it may be some silly mistakes or whether the textbook is wrong. So the question number 8, it says that form the differential equation for the family of ellipses having the foci and y-axis and center at origin. Means we have the ellipse like this, where the foci at this is AE0, this is minus AE0, and the origin this is here at 0, 0. Now the standard form of this ellipse is x square. The equation of such ellipse is x square over a square plus y square over b square is 1. Now we need to differentiate this equation. So here I write differentiating both sides with respect to x. So this becomes 2x over a square plus 1 over b square is constant, so I write 1 over b square here aside, and the differentiation of y square is 2y dy by dx equals 0. Now we can write this like this: 2x over a square equals to minus 2y over b square dy by dx. Therefore dy by dx, and I just take this 2 cancel, and then I write dy by dx times y by x. I'm just taking only x down and b square on this side along with this negative, so minus b square upon a square. So you see that dy by dx is there, it's fine. Now y is there still on the top, and x, this comes down here, and the minus I take it there and keep b square on the top, so it becomes like this. So that when I do it, because we have got the two parameters a and b, so it means we need to differentiate it 2 times. So just I want to make this subject so that all the constant comes in one time, and if I differentiate, both of them will be eliminated in one go. So here I differentiate. What I have to differentiate? I have to differentiate dy by dx. Y by x is minus b square over a square. Now differentiating again with respect to x, then what do we get? Now this is UV rule. It means you have to apply the rule of multiplication of differentiation. So I just write, I keep y by x constant, like the first. Suppose this is u, this is constant, I'm not changing anything, and I differentiate this one. That is, differentiation of dy by dx is d square y over dx square plus dy by dx, this time unchanged, dy by dx. Now I differentiate this y by x, but you keep this in your head, when you're differentiating y by x, again we have u by v rule. So I just go one go. So this is x into, in one go I'm just trying to solve this. So x into differentiation of numerator, that is dy by dx, minus y into differentiation of denominator, that is 1 over x square, and this on this side we have just constant, its differentiation is 0. So now I try to simplify, then I get y over x d square y over dx square plus x and this x dy by dx with this, so it is 1 by x dy over dx whole square minus y over x square dy by dx. Now to get rid of this x square, I try to multiply x square in each term. So what I get, that I write this one first, because I'm telling you I'm multiplying here by x square on all sides. X square, so this becomes x square into this becomes x y d square y over dx square plus 1 x square, because all these x square are going on the top, so this is 1 is getting, from the denominator the x is getting cancelled. This is x square, so this is x dy by dx whole square minus this is x, both x square and x square cancels, this is y dy by dx is 0. This is your final answer. Now question number 9. It says that form the differential equations of the families of the hyperbolas having the foci on the x-axis and center at the origin. So without drawing diagram is not necessary. If you feel like you can draw, if you remember the equation, because we need equation of hyperbola is x square over a square minus y square over b square is 1. It's very much same like ellipse, but only this minus sign is plus in the ellipse, and in the hyperbola it is negative. So just without wasting your time, let's differentiate it. Differentiating both sides with respect to x. So 2x over a square minus 2y over b square dy by dx is 0, differentiation of constant. So x over a square equals y over b square dy by dx. Therefore dy by dx times y by x is this b square over a square. Okay, so this part is now we have to differentiate this again. So differentiating again both sides with respect to x. Then what do we get? So here we get y by x unchanged. Now differentiation of dy by dx, that will become d square y over dx square plus dy by dx, this times unchanged. Now we have to find differentiation of y by x, that is u by v rule. So y by x, keep this in your head. So this is x into differentiation of numerator, that is dy over dx minus y into differentiation of denominator, that is 1 over x square, square of denominator, and on this side we have b square over a square, which is purely a constant number, and differentiation of that is 0. So now I have just to simplify this equation. So I can do that, I can just, there are many ways. I can multiply first this all equations by x square, so this x square gets cancelled. So what you get, xy d square y over dx square plus dy dx x dy by dx minus y equals 0. Now let me rearrange the terms. So we get xy d square y over dx square plus x dy by dx whole square minus y dy by dx is 0, and this is your final differential equation. Now question number 10. Form a differential equation of the family of circles having center on y-axis and the radius 3. So I have drawn this circle. Circle is, it can be anywhere on the y-axis. Center is at on the y-axis, you know, the coordinate of a point is 0, a, because on y-axis x part is 0 and the radius here is given as 3. We know that by definition of circles we can say AP equal to 3. AP is the distance between A and P. A is having the coordinate 0, A, and the P having coordinate x, y. So using distance between the two coordinates, we use the distance formula that says that x minus 0 whole square, that is under root of x2 minus x1 whole square plus y2 minus y1 whole square, and this is y minus a whole square is 3. Now just square it. So x square plus y minus a whole square, this equal to 3 square. So we have a as the parameter. Now we have to eliminate a. So what do? We just start differentiating. So differentiating both sides with respect to x. So we get 2x plus 2y minus a dy by dx is 0. So x plus y minus a dy by dx is 0. So we get y minus a dy by dx is minus x. Now we have to get rid of this y minus a, and here we have one equation which is going to help us. So what equation do we have? That is x square plus y minus a whole square equals 9. Now y minus a whole square, if I square this, then what I get, y minus a, first let me just write one simple form, that the y minus a can be written as minus x over dy by dx. So I write this dy by dx as y prime, because dy by dx is written as y prime or y dash. So here we have y minus a and we have to find y minus a whole square. So I just square this. So y minus a whole square is x square over y prime square. Now I put the value of y minus a whole square, replace this by this. So this is x square plus y minus a whole square, that is x square over y prime square equals 9. Then what do we get? So I write this as x square over y dash square equal to 9 minus x square. So x square is y dash square, and this is 9 minus x square. So this is our final answer. So so make it match with the answer of the textbook. I write, suppose I multiply both sides by minus, so it becomes minus x square is y dash square x square minus 9. So now I take this on this side, so we get 0 is y dash square x square minus 9 plus x square, and this is the answer. This answer is also same thing, only the form they look different. Question number 11 is MCQ question, which says that which of the following differential equation has y equals c1 e to the power x plus c2 e to the power minus x as the general solution. Now we have to differentiate it because we have got two parameters. Since it is MCQ, we can go directly. So what is y dash? That is c1 e to the power x minus c2 e to the power minus x. Simple. Now if you differentiate it one more time, y double dash, you get c1 e to the power x, and this becomes plus c2 e to the power minus x, because differentiation of e to the power minus x is giving you minus e to the power minus x. Now here you see that we find this equation, this part and this part are just same. Means what do we see? We find that y double dash equals y. It means our form goes like this. This, if I write in standard form, which you can understand, so d square y by dx square minus y is 0. So our option is B.